All right, section 3.5 is all about division of whole numbers. In grade 3, students should be able to both multiply and divide whole numbers, and they should see a lot of activities that help them to understand what's happening with multiplication and division. In particular, they should have lots of strategies based on the properties of multiplication and division to help them solve problems. So let's look at an example. This is the repeated subtraction model. So in this model, we're going to look at the example and you'll see where the repeated subtraction comes into place. So we have 18 cookies and we want to package them in cookie boxes that hold 6 cookies each. How many boxes do I need? So I'm going to fill one box and subtract the 6 cookies from the first box, or from the total. So I have 18 cookies. I'm going to subtract 6 and I'm left with 12 cookies. And I'm just going to repeat that process. So now I'm going to take 12 minus 6, that equals 6. And I have 6 cookies left. And finally, when I fill the last box, I'll have 6 minus 6, which is 0. So I have filled 3 total boxes. What did I do? I subtracted 6 from 18 until I got down to 0. Okay, so my conclusion here is that 18 divided by 6 equals 3. This should bring to mind for you the repeated addition model that we used to introduce multiplication in the last unit. All right, so here's another model. The set partition model has us take the set of elements representing the dividend and partition it into divisor number of subsets. So when I'm dividing, the dividend is the bigger number here, and the divisor is the number that I'm dividing by. Okay. So again, let's look at an example. We have 18 cookies again, but now we want to divide them among our 3 friends. How many cookies should each person receive? So in the set or the partition model, we're going to actually draw a picture of the set. In this case, we have 18 cookies we're going to draw, and we want to partition them into 3 sets of equal size. So the process you should have in mind is I'm going to take those 18 cookies and put them one at a time into each set, one to Bob, one to Dean, one to Charlie, and then go back to Bob, Dean, Charlie, and so on until each set has an equal number of cookies. Okay, and when you do that, you can see that each person ended up with 6 cookies, so we can conclude that 18 divided by 3 is 6. The missing factor model is based on the definition of division. So this definition is important. You should have it memorized this semester. We're going to define A divided by B to be equal to C if and only if C is the unique whole number satisfying B times C equals A. Okay, so there are 2 pieces to this definition. C is unique and it satisfies the multiplication problem B times C equals A. A little bit of vocabulary, we're going to call A the dividend, B is the divisor, and C is called the quotient. Okay, so the missing factor model has us rewrite the problem as a multiplication problem. So again, in our example of the 18 cookies and we want to divide them among 3 friends, then that means each friend has to receive C cookies, right? So in total, the 3 friends will receive 3 times C cookies. And so we're going to rewrite 18 divided by 3 equals C as a multiplication problem. That means that 3 times C equals 18. And then since we know that 3 times 6 equals 18, we can say that 18 divided by 3 is equal to 6. Okay, so we were able to fill in that missing factor. Now this again should remind you of a method that we saw earlier when we were working on subtraction models with the missing addend model. So we saw a couple units ago that subtraction of whole numbers is not closed. Similarly, division of whole numbers is not closed. So for example, if we wanted to find 27 divided by 5, what we would want is a unique whole number that satisfies 5 times c equals 27. But there is no whole number that I can multiply by 27. that I can multiply by 5 to get 27. Okay, so this has no meaning in the whole numbers, but it allows us to introduce the concept of remainders. So imagine that you had 27 marbles and you wanted to divide them among 5 friends and keep it even, so each friend gets an equal number of marbles. Then I could model that by drawing my marbles out. So I've got my 5 friends here, and I'm able to give each friend 5 marbles, but then I'm left with 2 marbles that I can't assign. So this is my remainder. Okay, so this is our first introduction to remainders for kids.